Alright, let's quickly work through the memo for the second assignment. So first up, we're told that the first three terms of an AP are these three terms. Okay? Now for A, given that the common difference is not 0, find the value of P. So for an AP, we know this. We know term 2 minus term 1 is equal to term 3 minus term 2. So we'll just plug those values in. So term 2 is 2p minus 6. So minus term 1, which is p squared over 6. And that has to be equal to term 3 minus term 2. Okay, on the left hand side here, let's just keep that as it is for now and multiply out the brackets on the right hand side. Equals, and then it's going to be p minus 2p plus 6. Okay, so let's collect everything to one side. So we'll have 2p minus p, or let me write it out. So we've got 2p, and then we bring this p across, so minus p, bring this minus p across, so we get plus 2p. And then we've got minus 6, so minus 12. And then we've got the minus p squared over 6. Whoops, let me write it a little bit better. P squared over 6, and we've got 0 on the other side. Okay, collect our like terms. So 2p minus p is p, plus 2p is 3p. And then we've got minus 12, and then we've got minus p squared over 6. So let's multiply everything by 6 to get rid of the fractions. So this is going to be 18p minus 72 minus p squared equals 0. Again, I'm just going to rearrange it and times by negative 1. So we'll have p squared minus 18p plus 72 equals 0. Okay, great. And now we can factorize this. There's going to be two brackets. And we'll have p times p to give us the p squared. And now we need the factors of 72 that can get us to 18 if we add or subtract them. So that's going to be, what is that going to be? Minus 6 and minus 12, right? Because minus 6 times minus 12 equals positive 72, which is correct for this one. And we've got minus 6 minus 12, which equals minus 18, which is correct for the middle term. All right, perfect. There's minus 6 and minus 12. P minus 6, P minus 12. And you can always test if this is correct by just multiplying this out and see if you get back to this answer. Okay, so now we know that either P equals 6 or P equals 12. Now how do we check which one is the correct one? Well, we substitute into P to see which one gives us 0 or which one does not give us 0, because we're not allowed to have 0 for our common difference. So our common difference is term 2 minus term 1, for instance. Minus term 1. So term 2 is 2p. So let's try 6 first. 2p minus p squared over 6. So, wait, I'm lying to you. Term 2 is 2p minus 6. And then term 1, so that's term 2. Term 1 is p squared, so 6 squared over 6. Okay, over here we got 2 times 6 is 12, minus 6 is 6. And then 6 squared is 36, divided by 6 is 6. So we get 0. So that's not going to work. So this one does not work. And now let's try 12. Same idea. So we again know term 2 minus term 1. So if we do term 2, we have 2 times 12 minus 6 minus, and then 12 squared over 6. Okay, so 2 times 12 is 24, minus 6 is 18, and 12 squared is 144, divided by 6 is 24. So then we get 18 minus 24 is negative 6. Let me just get a calculator out to make sure I did that correctly. Okay, so 12 squared divided by 6 is 24, correct, okay. And 18 minus 24 is negative 6. So this is fine, this is not 0, so that's what we want. So p equals 12 is our answer for that one. Great. So that is the answer to question A, p equals 12. Now question B. Question B, using this value of p, okay, so we know p equals 12 is what we want to use. Find the sum to infinity of the GP with this first two terms. Okay, so let's work out the first two terms. The first term, p squared over 6, so 12 squared over 6. And the second term is 2p minus 6. So the first term is 24. Oops, 24. And the second term is 24 minus 6, 18. Okay, so for our GP, we have that A, the first term is 24. And what is our common ratio? How do we find a common ratio? Common ratio is term 2 divided by term 1, right? So our common ratio is then term 2, which is 18, divided by term 1, which is 24. We can simplify that to 3 over 4. All right. And then, okay, so that's our ratio. Then the sum to infinity is equal to A over 1 minus R. As long as R is between negative 1 and 1, right? As long as R is between negative 1 and 1. And 3/4 is between that, so that is fine. Okay, let's plug that in. So A over 1 minus R. So that gives us A over 24 over, and 1 minus 3/4 is 1/4. And 24 divided by 1/4, I believe, is 96. Let's just do that quickly. So 24 divided by 1/4 is 96, correct. Okay, so there is our second answer, answer to number B. Question 2. So find the first three terms in this expansion in ascending powers of x. Okay, so remember this formula. If we have, let's say, I'm going to do x plus y. So if we have x plus y to the power n, then our first term is going to be n0, and then the first term to the power n, the second term to the power 0, plus the second term in our expansion is going to be n1, first term to the power n minus 1, second term to the power 1, and we keep going like that. Okay, let's just write the third term because we know we're going to have to find the first three terms anyway. So let me just move this to a place where there's slightly more space. Okay, and the third term will then be n2, first term to the power n minus 2, and second term to the power 2. Okay, now we can just use this to find our first three terms in the expansion. Okay, so let's do this. For number A, our n is 4. Right, let me just write this out. So 2 plus 3x to the power 4. Whoa. Okay, so our first three terms. So the first term is going to be 4, 0, right, because n is 4. And then our first term in the bracket is 2 to the power 4. And our second term in the bracket is 3x, and that's to the power 0. Plus. Then our second term in the expansion will be n1, so 4, 1. Our first term in the bracket is 2, so to the power 4 minus 1, right? N minus 1, so that's n. And then our second term to the power 1. Plus. Now for the third term, we've got 4, 2. And then our first term in the bracket again is 2. And then subtract 1 more from this exponent, so n minus 2 is 2. And then 3x. And then we add 1 more to what was here. So that's going to be 2. And we can see here, the 4 plus 0 is 4. 3 plus 1, 4. 2 plus 2, 4. So that'll always be the case. Just like here, n plus 0 is n. N minus 1 plus 1 is n. N minus 2 plus 2 is n. Okay, now let's calculate. So 4c0 is 1. 2 to the power 4 is 16. And then 3x to the power 0 is 1. plus. And again, we don't have to write out all these steps. I'm just doing that to show exactly what's going on in each step. Now 4c1, that's going to be 4. 2 to the power 3, that's 8. And 3x to the power 1 is just 3x. Plus. Now 4c2, that's going to be 6. And then 2 squared is 4. And then 3x to the power 2 is 9x squared. 9x squared. Okay, so 1 times 16 times 1 is 16. 16. Then we've got 4 times 8 is 32, times 3 is 96. X. And then I'm going to do 4 times 9 is 36, times 6 is 216. So 216x squared. So there we go. That's our first 3 terms in the expansion. Good. Ascending powers of x, so we start from x to the power 0, then x to the power 1, then x to the power 2. Alright, let's do number b. So number b, okay, that's the same thing. We just have a different expression here. So 1 minus 2x to the power 5. So for b, we've got 1 minus 2x to the power 5. Again, we need the first 3 terms. So let's do that. So again, we've got, for the first term, we've got n, which is 5, 0. Then we've got the first term in the bracket, which is 1 to the power 5. Second term, which is negative 2x to the power 0. Good. Second term in the expansion. Now we've got NC1. So 5, 1. Then we've got the first term in the bracket to the power 4. Second term in the bracket to the power 1. Plus third term in the expansion. So we've got 5, 2. The first term in the bracket to the power 3. Second term in the bracket to the power 2. Okay, those are our first 3 terms. So let's calculate. So 5c0 is 1. 1 to the power 5 is 1. Negative 2x to the power 0 is 1. Okay, 5c1, that's going to be 5. Then 1 to the power 4 is 1. And negative 2x to the power 1 is negative 2x. Plus, third term, 5, 2. So 5 choose 2, that's going to be 10. And then 1 to the power 3 is 1. Negative 2x all squared is 4x squared. 4x squared. Okay, let's simplify. 1 times 1 times 1 is 1. Then we've got 5 times 1 is 5. And 5 times negative 2 is negative 10. And then we've got all positive, so that's going to be plus. 10 times 4 is 40. And then x squared. So there is the expansion of the first 3 terms in this sequence. Great. Third question. Hence, find the coefficient of x squared in this expansion. Okay, so now we're just multiplying the previous 2 together. And we only need the first 3 terms of each. So I'm just going to write them out. Whoa, forgot to undo the triangle thing, or rectangle thing. So for question C, now I'm just going to write it like this. 16 plus 9x, 96x, sorry, plus 216x squared times, and then 1 minus 10x plus 40x squared. Okay, so to get x squared, we need to get all the combinations of x squared. So we can do, let me color code these ones. Okay, so we can do 16 times 40x squared. Whoa. Okay, so that's going to give us an x squared thing. So 16 times 40, what is that? That's 640, right? 16 times 40, 640. Okay, so then we get 640x squared. Then let's do these ones. So we've got 96x times negative 10x. Okay, that's going to be negative 960x squared. And let's do a blue one for the last one. So if we take this times this, that's also going to be an x squared term. So plus 216x squared. And now we just add them all together. Okay, so 640 minus 960 plus 216. Whoa, 216. So that's negative 104. Negative 104x squared. And we are just looking for the coefficient. So it's just negative 104. That is the coefficient of x squared. Good. Next up, question 3. So we are told the coefficient of x to the power 4 in this expansion is p, and the coefficient of x squared in this expansion is q. Okay, so let's start by just finding that before we even read the rest. Okay, so of x to the power 4. So if we think about the expansion of this first one, this x plus a to the power 6. Right, if we think about this expansion, the how manyth term will have x squared? Well, the first term is going to have x to the power 6, second term x to the power 5, and the third term is going to have x to the power 4. Right? So we need the third term. So for the third term, remember we start with the first term, that's going to be 6, 1, that's going to be 6, 2, that's going to be, so first term is 6, 0. Let me erase. The first term is going to be C0, 6, 0, then 6, 1 for the second, then 6, 2 for the third term. So for the third term, we're going to have 6, 2, then our first term in the bracket to the power n minus 2, so 6 minus 2 would be 4, and then the second term in the bracket to the power 2, because 4 plus 2 has to be the 6, the n. Okay, so let's calculate this. Ooh, 6c2. What is that? Is that 15? Let me calculate that quickly. So that's going to be 6 factorial divided by 2 factorial times, where's my times button? Times 6 minus 2, which is 4 factorial. That's 15, yes. Good. I guess that's going to be 15a squared x to the power 4. That's the third term. Okay, so they say the coefficient of x to the power 4 is p. So we know that p equals 15a squared, because that's the coefficient of x to the power 4. So there's our first bit of information. Now we can do the same thing for the other expansion. Let me just move these things a little bit over here, something like that. Okay, so over here, let's do the other expansion. So this expansion is for ax plus 3 all raised to the power 4. Now we're looking for x squared. So that's going to be the third term in this sequence again, right? Because we'll have 4, 0, and then we'll have x to the power 4, 3 to the power 0. The second term will be 4c1, then we'll have x to the power 3 and 3 to the power 1, and then for the third term we'll have 4, 2, x to the power 2 and 3 to the power 2. Okay, so this third term, this is the one we're interested in. Okay, so 4, 2, that's going to be 6, right? Let me just calculate that. So 4 factorial over 2 factorial times 4 minus 2, which is 2 factorial. Okay, so that's going to be 4 factorial is 24, 2 factorial is 2, 2 factorial is 2, so 24 divided by 4 is 6. Okay, so we're going to have, so this part here is 6, and then 3 squared is 9. And then we've got x squared. So we've got 54x squared. Oh, sorry. My bad, I forgot the a with the x here. So that a. So this is going to be, so a squared x squared. Sorry, let me just go away here. So now 4c2, that's going to be 6, and then 3 squared is 9, and then a squared x squared. So a squared x squared. Okay, so 54a squared. So 54a squared is going to be the coefficient. So we know that is equal to q. So q equals 54a squared. Okay, very good. Now we're told that p plus q equals 276. So p plus q equals 276. Okay, so 15a squared plus 54a squared is 69a squared equals 276. And then 69 times what gives us 276? That's going to be times, so 70 times 4 is 280. So 69 times 4 is 276, yeah. Okay, so divide by 69 on both sides and we get 4. So a is then equal to the square root of 4, which is plus or minus 2. So a is 2 or a is minus 2. Okay, I know this sounded a bit messy going through this, but if I looked at the papers, it looked like most of you guys got this right. You had the right idea, found the correct term, correct coefficients, and then solved correctly. Very good. Okay, but let me know if there's anything that you don't understand about this part. We can go through it again. Question 4. Let's do this one in blue. Okay, so they tell us the second term of a GP is 16. Okay, so again, what does a GP look like? GP has this form, right? Okay, so the second term, that means n is 2, is 16. So the second term is 16, that means a r to the power 2 minus 1. So it's just that. And we also know the sum to infinity. So sum to infinity, remember, that's a over 1 minus r. So the sum to infinity in this case is 100. So we know that 100 equals a over 1 minus r. So now we have two equations. Let's call that equation 1 and that equation 2, and then we'll solve them simultaneously. Okay, so we need to find two possible values for the first term. So now it doesn't matter if you get a or r by itself first. It really doesn't matter. Yeah. So I'm going to say, what do I want to do? I'm going to say let's get rid of the fraction here. So let's multiply both sides by 1 minus r. So that's going to be 100 times 1 and 100 times negative r. So minus 100r equals a. So now we have a by itself. So we're going to substitute this new equation 2 into equation 1. Okay, so equation 1 is 16 equals a, but a is just 100 minus 100r. And then a times r. Okay. So now we're going to multiply out. So we get 100r minus 100r squared. And I'm going to get everything to one side equal to 0 because it's a quadratic equation. So 100r squared minus 100r plus 16 equals 0. We can divide everything by 4, I think. Looks good. So 25r squared minus 25r plus 4 equals 0. And now we can factorize this one, it looks like. Okay, so to get 25, we can do 20 times 5, and that's going to give us 100, which is perfect. So we're going to say 20r, and we're going to say, not 20r, we're going to say 5r and 5r. And then we need, so minus 4 and minus 1. That's right. Okay, so that gives us r equals 1 over 5, or r equals 4 over 5. Okay, so now we have r. So now we need to find a still. So now we can put this into either one of our equations. I'm going to use equation 1 again. So equation 1 was 16 equals AR. So we're going to say for this one, 16 equals A times R. And for this one, we're going to say 16 equals A times R. All right, so divide both sides by 1 over 5. So 16 divided by a fifth is 80. And then 16, so times 5 is 80, divided by 4 is 20. Okay, so those are the two possible values for A. Nice. Now show that the nth term of one of the two possible geometric progressions is equal to 4n minus 2 times by the nth term of the other geometric progression. Okay, so I've also seen in history past that the longer a sentence is, the more difficult people find to answer the question. So let's see what we can do here. So basically, we know we're going to be working with the two different nth terms. So let's just first find the nth term for both cases. Let's switch colors for the second question here, for B. Okay, so we want to Tn equals AR n minus 1. So we want to find this for both options. So the one option is Tn equals A, which is 80 in the one option, and the R for this 80 is 1 over 5, right? So 80, 1 over 5 to the power n minus 1. And the other option is Tn equals A, which is 20 in this case. And in this case, if A is 20, then R is 4 over 5. So 4 over 5 to the power n minus 1. Perfect. Now we have the two equations. Now we want to show that one of them is equal to 4 to the n minus 2 times the other one. Okay. So I'm going to, I think prime factorization will be our friend here. So let me prime factorize this just to simplify it in that sense a little bit. So 80 we can say is 2 to the power 4, 2 to the power 4 times 5. So that's 80. And then we still have the 1 over 5 to the n minus 1. For the other one I'm going to do the same. So 20 is 2 to the power 2 times 5. 2 to the power 2 times 5. And then we've got 4 over 5 to the power n minus 1. Okay, so now we see we have a slight problem here. We've got this 4 over 5, and here we've got 1 over 5. So let's change this one up a little bit. So we're going to say, we're going to keep this, 2 to the power 2, 5. But now, this one we're going to split up. We're going to say 4 over 5. 4 over 5 is just the same as 4 times 1 over 5, right? And if we have this, so that's the same as this thing here. So if we have this, we can take the n minus 1 exponent to both things inside. So we can say that is 4 to the power n minus 1 times 1 over 5 to the power n minus 1. So that's what I'm going to do here. So I'm just going to split this up into this. So times 4 to the power n minus 1, and then 1 over 5 to the power n minus 1. Okay, let me erase this again. So now we're starting to get somewhere. We already have a 4 to the power n minus 1 idea, which sort of makes sense here. Now let's continue with this one and simplify it more. So 2 to the power 2 is just 4. Okay, so I'm going to say 2 to the power 2 is just 4. And then I'm going to put this 4 to the power n minus 1. And then we're going to say the 5 times the 5 that we have here. And then the 1 over 5 to the power n minus 1, just to rearrange it a little bit. And now we can combine these 4s. So this is 4 to the power 1, right? So if we multiply and the base numbers are the same, we add the exponents. So 1 plus n minus 1 is just n. Okay, times 5 to the power 1 over 5 to the power n minus 1. Okay, so now it's pretty similar. So this one here has 2 to the power 4, which I'm just going to rewrite as 4 squared, just so we have the same basis. So here we have now 2 to the power 4 is the same as 4 to the power 2. Right? Both of them are equal to 16. 5, 1 over 5 to the power n minus 1. All right. So now we are getting there. Pretty close. Now it's the time when we want to do a bit of magic. So I think the one part that was difficult or interesting to try to see what was going on was to rewrite this as 4 to the power n minus 1 times 1 over 5 to the power n minus 1. So I think this was one difficult part, to rewrite that. And now the next part is from here. What do we do from here? So what do we do? So we've got a clue. We've got a 4 to the power 2, we've got a 4 to the power n. So that gives us a clue here. 4 to the power n minus 2. That involves both of those ideas. So what I'm going to do is I'm going to say, let's multiply both of these equations by the same thing. Okay? And see what happens. So I'm going to say, multiply this equation by 4 to the power negative 2. And multiply this equation also by 4 to the power negative 2. And then we see what it comes up with. Okay, so that's going to give us Tn equals, now if we multiply 4 to the power 2 times 4 to the power negative 2, so we've got 4 to the power 2 minus 2, 4 to the power 0. And what is 4 to the power 0? That's just 1. So these two cancel out now. And we're left with 5 times 1 over 5 to the power n minus 1. Okay, and for this one, now if we multiply 4, bases are the same, we add the exponent. So n plus negative 2 is n minus 2. And then we've got 5 times 1 over 5 to the power n minus 1. But this is just the same as that. Okay, so we've shown that. So the one equation, the one Tn formula, is equal to 4 to the power n minus 2 times the other Tn formula. And now, so we've shown it. Okay, a little bit tricky, I think, and there's probably a much quicker way to do this than what I just did. This is just the first thing that came to my mind, to do it this way. I'm sure there are faster ways, but at least we get the idea. Right, so we understand that we want to write this as, so the Tn for, let's call it Tn1, is equal to 4 to the n minus 2 times the other Tn. And that's the idea, right? So this Tn is equal to 4 to n minus 2 times the other Tn. And there we've shown it. Okay. Let me do this. I'm going to duplicate this page and then get rid of all of this. So we still have that on the other page, because I'll probably just export this as a PDF for you guys as well. Get rid of all of this so we can do the last question. I suppose I could just, this will be a bit quicker. Okay, good. Now last question. So solve for k here. Okay, so this is sigma notation. That just means the sum of. Is this something I can erase? Yeah. Okay, so the sum of. So what we usually want to do, what we said in class, is we get the first 3 terms and then we work from there, just to get an idea of what the expansion looks like. So here we say we start at I equals 3. So our first term will be 2 times I, which is 3, minus 5. So our first term is going to be 1. Second term, 2 times 4, minus 5. So 8 minus 5 is 3. And then our third term, 2 times 5, minus 5. 10 minus 5 is 5. Okay, so those are our first 3 terms. So we can see it makes an AP, right? We're adding 2 each time. So that's an AP. So we know our first term in our AP is 1. Our common difference is 2. Okay. And now we are told to sum. So let's also write the Sn formula. So Sn for an AP, n over 2 times 2a plus n minus 1 times the common difference. Again, what does this n mean? N is the how many terms we want to add, right? The sum of n terms, the number of terms. So what will n be in this case? So remember, if we have this, and let's say from, okay, so let's do this one we actually have here. So the number of terms is going to be the top minus the bottom plus 1. So our number of terms for our equation is going to be top, which is k, minus the bottom, which is 3, plus 1. So if we simplify that, we get k minus 2. So that is our n that we're going to use in this formula. Alright, so let's use that. So Sn, so the total, the sum is 784. So 784 is equal to n over 2, but our n is k minus 2. So n over 2, 2a, what is our a? Our a is 1, right? A plus n minus 1. So k minus 2 minus 1 is just k minus 3. So n minus 1 times our common difference, which is 2. Okay, and now we solve for k from here. So I would say let's get rid of the fraction first. So times both sides by 2. So what is 784 times 2? 1568. Okay, 1568 equals k minus 2 times, and now in here we can simplify first here. So if we multiply that in, we get 2k minus 6, and then we get plus 2. So that's just 2k minus 4. So 2k minus 4 in this bracket. Alright, let's multiply out the brackets. So that's going to be 2k squared minus 4k, so minus 8k, and negative 2 times negative 4 is 8. So let's get everything on one side equal to 0. So 2k squared minus 8k, and then 8 minus 1568 is negative 1560. Let's divide everything by 2 just to make it a bit simpler. So k squared minus 4k minus, what is this now? 780. 780. Okay, what? So 4. So it has to be two numbers that are pretty close together to get to 780. What about 30 and 26? Because 25 times 25 is like 625, 30 times 30 is 900. This seems roughly in the middle there somewhere. So let's say, what, 30 times 26? 780. Okay, perfect. Good guess. Good guess. Okay, so we can factorize this. You can also put it in the quadratic formula. That's usually what happens when we get these types of questions. The numbers are so big, it's quite difficult to factorize quickly. So often we just put that in a quadratic formula to solve. Okay, I would have also done that if it didn't work out quickly with a guess. So we have minus 30 and plus 26. So we get k equals 30 or k equals negative 26. This one does not work, right? Because we can't have a negative number of terms that we sum. We can only sum terms that exist. So for first term, second term, third term, we can't sum before we start even. So k equals 30. And that is our answer. Okay, now just as a side note, we could have also ignored this to, we could have also ignored this to start with and then just did that at the end. So we make a note of this, but then we could have also just solved with n instead of k minus 2. So let me just do that as an extra side note. So we could have said 784 equals n over 2, 2a plus n minus 1 times the common difference, right? So just use n. So at least now I know the numbers. 1568 equals n, and in here it's going to be 2n minus 2 plus 2. So that's just going to be 2n. Is that right? 2 plus 2n minus 2. Yeah, 2 minus 2 cancel out, so it's just that. So then we get 0 equals 2n squared minus 1568. So let's divide by 2. So n squared equals 784, minus 784. And then does that work out? 2a plus n minus 1 times d. Let's quickly check. So the square root of 784, does that work out? Or did I make a mistake somewhere? 28. Okay, so n equals plus or minus 28. Well, let's do the factorizing. Difference between two squares since things are on the same side. So n minus 28 and n plus 28. Okay, so that gives us n equals negative 28 or n equals 28. This one won't work, but we know, let's say, but n equals k minus 2, right? N equals k minus 2. So that means 28 equals k minus 2, and then we just bring the 2 across, so 30 equals k. So you could have also done it like that if working with the whole k thing in here makes it seem too complicated. You could just start with n, and then replace the n equals k minus 2 later. And how do we get k minus 2 again? Top minus bottom plus 1. K minus 3 plus 1. Okay, I hope this was a useful memo.